Bismillahirrahmanirrahim. Today I'd like to talk about sectors and segments. What you see here before you, of course, is circle Q. And I have selected 2 points from the circle, point A and B, and drawn out this arc. And you would label this arc, of course, as thus, arc AB with the 2 endpoints. Now, if I were to draw out the 2 radii over here, like this shaded region right here is a sector. So a sector is part of the area of the circle, if you like to think a slice of the cake, a slice of pizza, or pie. So this slice over here of the circle is called a sector. A sector of a circle is a region that is bounded by 2 radii. A sector of a circle is a region that is bounded by 2 radii and an arc of the circle. So you describe a sector based on its boundaries. It's bounded by 2 radii and an arc. So a sector of a circle is a region of the circle that is bounded by the 2 radii and the arc that's between the 2 radii. So this is a sector. Now you label this as simply as sector AQB. That's how you would call this particular sector. Now, if I were to connect these 2 points, points A and points B, with the chord like this would be a segment. So a segment of a circle is that part of the area of the circle that's between a chord and this particular arc. Okay, so that is a segment. So if you recall from before, the central angle determines the measure of an arc. So here you can say the measure of arc AB is 60 degrees like this. Okay? And I had also suggested before that the length of the arc, or arc length, is calculated by taking a fraction of the circumference of the circle. Correct? And that circumference is based on the measure of the arc. So if you have the arc measure, so you have the measure of the arc over 360, and that's going to be the fraction that the arc has of the entire circumference. So arc length we had defined previously as some fraction of the total circumference. In this case, this arc here, right, is a fraction of the entire circumference of the circle. In the same way, the area of a sector is some fraction of the entire circle. Correct? So in this case, it's going to be the same fraction as the arc length because the sector is bounded by an arc. Because the sector is bounded by the arc, the measure of the sector is going to be the same degrees as that of the arc. So the measure of the arc, or the central angle, out of 360 degrees is going to determine the fraction that the sector is of the entire circle in the area. So finding the area of the sector is simply a fraction of the total area of a circle. Okay, so, and if you recall, area of a circle, of course, is pi r squared. So if this particular circle was, let's say, we just previously, as we had said, the radius is 2, we can find the area of this particular sector by saying, well, the area of this circle is pi r squared. The r is 2, that's going to be 4 pi. Then the area of the sector is going to be the fraction. Now we suggested this was like a 60-degree angle, right? So the area of the sector is going to be that fraction, the 60 degrees out of the 360 degrees of this area of the circle, which is pi r squared, which is 4 pi. Correct? So this is 1/6. 6 goes in there. So this is 1/6 of 4 pi, and you can simplify this, of course, and here it goes, 2 goes in there 2 times, 2 goes in there 3 times. You can simplify this as 2/3 pi if I did the math correctly. So the area of the sector here is going to be 2/3 pi. So the concept of the area of the sector is very similar or analogous to the concept of the arc length. Whereas an arc is like a little thread area, just like a little distance from point A to point B on the circle over here. The sector, however, is an area. It's like a slice of the pie or the pizza, as we have suggested. But nevertheless, the area is going to be some fraction of the area of the entire circle. Now, if you wanted to find the area of this particular segment, how would you go about doing that? Well, let me suggest to you with an example. Now, consider this circle C over here. I have drawn over here a central angle that is 90 degrees, like thus. And then I have drawn this chord over here, chord AB, which then creates this particular segment. Now, I want to find the area of this segment that's created by the chord AB, or that's bounded by the arc AB. Now, let's just say here that the radius here is 10. So the question is, what is the area of the segment here? Well, the way you would find the area of the segment is you can find the area of the sector, correct? You can find the area of the sector. So let me just draw the sector by itself kind of like this. So you can find the area of the sector. And then you can subtract away from there. You can subtract away from this the area of this triangle. And what you'd be left, it would be the area of the segment. So if you wanted to find the area of this segment, okay, so the way you would do that, you would find, here you go, so area of the segment would be the area of the sector minus the area of the triangle here. So the area of the segment is going to be the area of the sector, the whole area here, and minus the area of the triangle. So let's find that. So area of the sector here, it's going to be 90 degrees over 360 degrees. It's going to be that fraction of the total area of the circle, which is going to be pi times r is 10, pi r squared. And then from that, I'm going to have to subtract the area of this triangle over here. Well, it happened to be a nice right triangle, right? So it's 1/2 the base. You can choose any base because it happens to be a right triangle to make it easy for us. So 1/2 the base, which is 10, times the height, which is also 10. If you remember, the area of a triangle is 1/2 the base times height. So that's easy. Now this is going to be 1/4, of course. So this is going to be 1/4 times 10 squared is 100, 100 pi. And minus, that's minus 50 over here like this. So, and 4 goes into 125 times. So this is 25 pi minus 50. So the area of the segment is going to be 25 minus 50. Now that completes our introduction today on sectors and segments. As a review, a sector is an area of a circle that's bounded on two sides by the radii, and the third side is bounded by an arc like this. The area of a sector can be calculated similar to how we calculate the length of an arc. Arc length, if you recall, is calculated by some fraction of the circumference of the circle. Which fraction is the measure of the arc as measured by the central angle over the entire 360 degrees. That fraction of the circumference of the circle, which is of course 2 pi r. And then similarly, area of a sector is calculated by a fraction of the entire circle. The central angle that creates the arc is the same central angle that creates the sector. So the fraction of the sector over the total circle is going to be the measure of the arc, or the measure of the central angle, which is the same, and over 360 times the area of the circle, pi r squared. And finally, as a review, we talked about segments. Segments is that part of a circle that's bounded on one side by a chord and an arc on the other side. If you wanted to calculate the area of the segment that's created, you have to first find the area of the sector and subtract from it the area of the triangle, and then you would get the remaining area, which would be the area of the segment. Until next time, assalatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.